Good morning, everybody. My name is Lucas Bednarik. I'm a first-year student here at Colorado Law, and I've been enjoying being involved with the Silicon Flatiron Center, and I'm grateful for the opportunity to introduce our band access panel today, beginning with John Chapin, who's a senior fellow of Silicon Flatirons and former special advisor for Spectrum at the National Science Foundation. David Goldman, who's Vice President of Satellite Policy at SpaceX. Monisha Ghosh, who is a Professor of Electrical Engineering at University of Notre Dame, Policy Outreach Director for Spectrum X at the National Science Foundation, and co-chair of the FCC's Technological Advisory Council. Rob Alderfer, who is Vice President of Technology Policy at Charter Communications. Shawn Bone, Senior Director of Public Policy at Verizon, and Michael Calabrese, Director of the Wireless Futures Program at New America Foundation's Open Technology Institute. So if you'll join me in welcoming our band access panel.
Great. Thank you, Lucas. And thanks, everybody. So we're really excited to have this fantastic panel here today. I certainly appreciate ARPAN's call for us to focus on a path to abundance. And in this world, spectrum abundance is definitely a means to an end. As he said, the end goal is to make the best services and capabilities available to the most users. So in this panel, we're going to use that lens to look at developments that happened in 2025. We're going to ask what those developments mean for progress towards making great services and capabilities available more widely. We're going to talk about what went right in 2025, what went wrong, and how the competitive environment has changed. Are we on the path towards the world that ARPAN envisions, where users are protected by exit opportunities, choice, and intermodal competition? Or are there course corrections we could make that would accelerate progress and mitigate risks? The panel does have a bit of a focus on dynamic spectrum sharing, but I know the discussion is going to be broader than that. By way of introduction to activity of 2025, I'm going to briefly review one of the major developments in spectrum policy, which is the One Big Beautiful Bill Act, OB3. That bill reinstated FCC auction authority and extended it to September of 2034. It requires that 800 megahertz of spectrum be auctioned by 2034. 300 megahertz, that would be federal, non-federal, or both, 500 megahertz of federal spectrum, and it has to be below 10.5 gigahertz. The auction timeline, that, by the way, is a lot of spectrum, at least feels like a lot from where we sit, given how hard it is to free up spectrum for auction. And then the timeline's really fast, 100 megahertz by July of 27. So you know there's people in the government who are sweating bullets over that right now. 200 megahertz by July of 29, and the remainder by September of 2034. And the bill does mention a set of specific bands, which I expect that the panelists will end up mentioning in some of their remarks. 2.7 to 2.9 gigahertz is to be studied. That's currently used by the FAA, weather, and DoD radars. 4.4 to 4.9 gigahertz, currently used by fixed and mobile tactical systems for the DoD and a bunch of fixed microwave links. And 7.25 to 7.4 gigahertz, currently used also by the DoD and by others for military SATCOM and for fixed microwave links. On the other side of the coin, the bill excluded certain bands from auction. The lower 3 gigahertz, 3.1 to 3.45, and the 7.4 to 8.4 gigahertz band. Both of those are federal bands with complex ecosystem of diverse uses. So I'm imagining, just giving you that review because some folks will probably be mentioning it. Here's how the panel will go. I'm going to invite the panelists each to give a 5-minute opening remarks on the key questions. What went right in 2025, what went wrong, and how have things changed? And then we'll collectively give you a very short tutorial on what spectrum sharing means, because that's a fairly ambiguous or broadly defined term, and it has different meanings in different categories of spectrum. And then we'll have questions from me and from the audience. Now I'm going to mix things up a little bit, and I'm going to surprise Michael by saying we're going to start from the other end of the table and come this direction. Just to keep you on your toes.
Yeah, okay.
Yes.
See, I was just getting relaxed.
Yeah, you might want to say a few words about yourself, and everybody can as well before launching into your remarks.
Okay. Yeah. Again, Michael Calabrese, I direct wireless feature at New America, and have been engaged, mostly representing a coalition of public interest groups. We have a public interest spectrum coalition, consumer school, library, civil rights, and other groups, mainly to make wireless connectivity more abundant and affordable, and to close the digital divide in as many ways as possible. So I would, in terms of what went right and what went wrong in the spectrum world, 2025, I would say 2025 was, from our perspective, a tale of two policy domains, terrestrial and non-terrestrial. So advances in sharing for terrestrial use were effectively put on hold, and with new uncertainty created that the U.S. might even reverse advances it's made, very recently in greatly expanding shared spectrum for unlicensed Wi-Fi primarily, and shared spectrum for private networks. At the same time, and more dramatically, Chairman Carr and the Space Bureau launched a virtual revolution in expanded sharing of satellite spectrum. So let me take each of those in turn. David Goldman can get, well, I'm sure we'll give some more detail, but I did want to mention that satellite spectrum abundance became a theme in multiple proceedings last year, and literally the name of one of the first of those to allocate thousands of additional megahertz of high band spectrum to LEO satellites in particular for sharing, because all satellite spectrum under the ITU and US law is shared. Then another proceeding is on the spectrum sharing between LEOs and GEOs. So LEOs being the low Earth, GEOs being the geosynchronous in high orbit, is proposing much higher power, more beams, and moving away from the ITU's very restrictive rules. And then an NPRM late last year has proposed to expand sharing with mobile carriers in the millimeter wave bands to expand and streamline access to sites for Earth station gateways that backhaul satellite data traffic for these mushrooming constellations of LEOs in particular. Now, terrestrial spectrum was, very much, again, from our point of view, a contrast to that. The One Big Beautiful Bill, OB3 Act, created a sort of regulatory distortion field. So by, in terms of how much it focused only on more spectrum for exclusive licensing, 800 megahertz, as John just said. And it's an interesting contrast also to the first Trump term under Chairman Pai, which represented the high watermark of balanced spectrum policy of all time. In 2020 alone, the FCC authorized, or they began the auction for 280 megahertz in C-band for exclusive licensing for mobile use. But it also allocated 1,200 additional megahertz across the entire 6 gigahertz band for unlicensed sharing, and launched CBRS, both holding the auction for the priority access licenses and opening the band even before that for general authorized access, because the band is half and half. We'll probably get back to that. But last year, OB3 not only mandated 800 megahertz for auction, in the process, it put great pressure on regulators to delay or even possibly roll back progress on shared and unlicensed spectrum. That's how difficult it will be to meet that now statutory target. So I've closed by mentioning, the two specific things we care about, in particular CBRS, the Citizens Broadband Radio Service, went into the year with high hopes, thanks to the US Navy and NTIA agreeing on CBRS 2.0 hugely relaxing the constraints on sharing that band with Navy radar. And so there was a real boom in deployments by enterprise, WISPs, and others. But 2025 added uncertainty, or OB3 in particular added uncertainty, including around at the FCC, a proposal to relocate CBRS, or alternatively to make it more like a traditional very high power mobile band, which we've opposed. And then on unlicensed, OB3 created uncertainty, but also seemed to sideline consideration of an obvious next advance in unlicensed, which is to extend that 1200 megahertz I mentioned, an additional 125 megahertz into the 7 gigahertz band to accommodate the very wide channels that next generation Wi-Fi is bringing to market right now. On the bright side though, just as the last point, FCC completed work on an expansion of the utility of 6 gigahertz unlicensed, and just in January adopted an order creating a new device class, geofenced variable power, for peripherals like, AR glasses and VR headsets and so on, and also proposed to allow higher power for indoor use if it's controlled by the Automated Frequency Coordination Database. So that was very much, we hope, the beginning of a positive year for 2026. Shawn?
All right. I guess it's my turn. So Shawn Bone, Senior Director of Public Policy for Verizon, have been at the company just over 4 years and spent a decade on Capitol Hill before that. For the mobile wireless community, 2025 was a very important sort of year. As John described, we spent a lot of time talking to Congress and have spent years actually previous to last year talking to Congress about the need to restore the FCC's auction authority, which had expired, as well as sort of create a pipeline or a plan for what it was going to do with that auction authority. So what we got out of OB3, as John described, was a 9-year extension of auction authority and a plan for how that is going to go forward, targeting 800 megahertz of auctionable spectrum over that 9-year period. I would maybe describe the bill a little differently than Michael, and we're going to mix it up here. It's going to be fun. The political context of the bill is important, and I hate to put my congressional hat on for a moment, but for those of you in the room who aren't familiar with the reconciliation process, that process, which was how the tax bill, which included the spectrum provisions, got passed, creates an important structure around the ability of Congress to do certain things. Reconciliation focuses on federal government revenues, raising revenue and taxation. So when you're putting bills into a reconciliation vehicle, it has to have a direct relationship to raising revenue for the federal government, which is why ultimately the OB3 text only focused on auctionable spectrum, because at this point, according to the Congressional Budget Office and many others, the only type of spectrum that actually raises revenue directly for the federal government is auctionable spectrum. That does not wipe out conversations around other types of spectrum, both in Congress and at the FCC. It just creates a fine point on auctionable licensed spectrum going forward, which we felt was important because what we have done over time as the mobile wireless industry is sort of think about how we plan network expansion and development over the life cycle of, auctions at the FCC. And it's helpful when we have a pipeline to be able to think about how mobile and wireless industry is not here for conversations about shared spectrum bands, unlicensed bands. We utilize all sorts of different types of spectrum access models in our networks. But the OB3 bill, because of the political context around it, had to focus on auctionable spectrum. So yes, John laid out the timeline. I would also push back a little bit on Michael's characterization of what OB3, the statute, does and the conversation that we're likely to have on this panel about what the statute means. The statute just says, go auction 800 megahertz of spectrum over the next 9 years. 300 of that has to be repurposed commercial spectrum. 500 of that has to be repurposed federal spectrum. It also says go study the 3 bands that John mentioned. It does not actually tie the studies to the auctions. It just says go study it. Now, there has been a subsequent presidential memo that says some of the spectrum that is going to be auctioned is from the 7.125 to 7.4 band. That was an exogenous factor that wasn't part of the statute. So yes, we're going to have a lot of conversation up here about particular bands and the future of bands or whatnot. But I disagree with Michael in that that's not coming from the statute. That's coming from the larger conversation around it. And many of those decisions are going to be in the hands of people like Arpin at the FCC about where this is going to go. So those decisions haven't been made yet. There's nothing, in the statute necessarily that says you have to stop enhancing CBRS. We're actually advocating for enhancements to CBRS. The other thing I do want to say in the statute that was important to the mobile wireless industry was Congress's recognition of the importance of power levels when you're thinking about spectrum for mobile wireless networks, and the reinforcement of the value of flexible use licensing. I've been on many panels next to Rob and others and I expect again, we'll talk today about the delineation between the use of mobile wireless spectrum for mobility and for fixed wireless access. The good thing is that's not a policy decision. That is a technical and innovation decision on the part of the mobile wireless carriers to figure out how to best serve its customers no matter where they are. The same is true of, former Senator Gardner's comments this morning about how the cable industry is making inroads into the wireless marketplace. They're actually using, in many respects, our network to begin that inroads and then layering on their own build out on top of that. So this is the conversation and the framing of this is important when you think about service to the consumer and the ability of companies to figure out the right way to utilize the spectrum. Hand it over to you, Rob.
Thanks, Shawn. And thanks to John for putting together this panel and to Matt and the Silicon Flatirons team for a great conference. It's always a good discussion here. I'm Rob Alderfer. I'm in the technology organization at Charter Communications. For those of you that need a brief intro to Charter, we're one of the largest communication service providers in the US. We offer broadband, voice, video, and mobile service across 41 states under the brand name Spectrum, which is fun because we're here talking about Spectrum, and I actually get to speak not only about Spectrum, but on behalf of Spectrum. So in terms of what went right, John, in 2025, I thought Corey Gardner did a good job earlier of laying out the really dynamic market landscape that we have today in the US in the communication sector. I just want to highlight a few points that'll help to frame the discussion in that regard. So in 2025, between Comcast and Charter, together we now serve over 20 million, well over 20 million mobile subscribers. And Charter's now the fastest growing wireless operator in the country, which is something we're really proud of. That's a function of offering really great service at a great value for customers. And CBRS, which Corey Gardner also mentioned earlier, we'll talk more about today. And to define that acronym, I think we should do our best to define acronyms today. Citizens Broadband Radio Service, which is a frequency band that is the archetype of shared spectrum. CBRS is increasingly fueling our mobile growth, and we're deploying that rapidly. Not just within the cable industry, but really across the communications sector. There's over 420,000 CBRS radios deployed, and that's not only helping to fuel mobile competition through improving the economics of cable operators like Charter as we enter the mobile space, but it's also allowing manufacturing entities, healthcare, logistics, and a range of economic sectors really take control of their own wireless operations through private wireless network. Companies like Walmart, Tesla, John Deere, Chevron are all in the CBRS space, as well as the communications sector and players like Verizon, who's a big deployer of CBRS, and Charter. So beyond CBRS, 2025 was also a big year in Wi-Fi in terms of the ramp of 6 gigahertz Wi-Fi deployment. Charter has well over 6 million 6 gigahertz capable Wi-Fi access points deployed across our customer base, and we're making full use of this new spectrum band for Wi-Fi. So that's gone hand in hand with the expansion of our broadband capabilities. We're deploying new fiber networks across the country. Just in 2025, we lit up 1.5 million new network passings. And we're also upgrading our existing network to multi-gig services throughout the country. And at the end of all that is Wi-Fi. So 6 gigahertz Wi-Fi is really what makes that investment. And so much of the investment that we heard, not just from private sector operators, but also from the government on the last panel, 6 gigahertz Wi-Fi is really what makes that real for consumers, because ultimately that's how consumers connect to those broadband networks. And so that's, I think, some highlights for us in terms of what's happening in the market and what some of the major developments in 2025 were on that front. In terms of the policy front, obviously, John, you laid out the restoration of the FCC's auction authority through the OB3 bill. That generally, I think, was a step forward, needed to be done to set the path for continued access to commercial wireless spectrum to continue to fuel growth and competition in our sector over the next decade. And it did have ambitious and specific targets, I would say, for making spectrum available. And I would note, importantly, it does not preclude shared spectrum. So how much spectrum is needed, what the trade-offs are relative to network investment, because those two things are trade-offs, in fact. Spectrum and network investment are two distinct ways to meet growing capacity demands for wireless services. And what the most efficient way is to meet those demands all really require careful evaluation. And I hope we don't lose sight of that as we talk about the path forward under the OB3 legislation. And to that end, I think it's important to keep in mind where capacity demand is growing. The vast majority of wireless data is consumed in specific locations like homes, offices, campuses, venues. That's intuitive if you just think about how you use your own devices. And that's really where capacity demand is highest. That's where spectrum needs exist. And we see that across communications operators. For all mobile operators, well over 80% of the data from mobile devices is actually traveling over Wi-Fi. At Charter, on our Spectrum mobile service, we do a bit better than that. We're about 90% of traffic from Spectrum mobile devices is handled over Wi-Fi. So we need to continue to feed the Wi-Fi spectrum pipeline. And Michael, you mentioned the lower 7 gigahertz band as an opportunity to do that. I'll close on this. This is a real highlight for me in 2025. At Charter, we worked with Broadcom to develop a new technology innovation that stitches together the existing 6 gigahertz spectrum with the lower 7 gigahertz spectrum. And we showed this at an industry conference in DC back in the fall. We were able to get up to 20 gigabits per second to consumer devices using those two bands together. And so as we think about the future of wireless and spectrum policy and how it needs to meet consumer demands, that we see as a real opportunity that we need to keep front of mind. So I'll leave it there. Thanks.
Thank you. It's a little bit hard to say something new after the excellent summaries given by the previous panelists. Thank you again for inviting me to the panel. It's been a great conference so far. I'm Monisha Ghosh. I'm a professor at the University of Notre Dame in the Department of Electrical Engineering. I've been there about 4 years, but I have been working on spectrum-related issues for my entire career, which is, I won't date myself as to how long that is. Suffice to say that I worked on the HDTV broadcasting system, which many in the room may be too young to even remember a time when we didn't have digital TV. And I've been in spectrum sharing since 2008. So I've wound my way into academia through working in industry for many years, stint in government, and now in academia. So I'll come to this question and the panel and what we've been tasked with a slightly different angle to really look at tying together what was talked about in the previous talk by Arpan on spectrum abundance and what the legislation did. To me, there is a fundamental contradiction if you're trying to do spectrum abundance and you take 800 megahertz and you allocate it to one kind of use. So as we look forward as to how we address some of these issues, I I take a lot of insight from two other related industries. One is real estate, one is transportation. So if you look at real estate, what we do in New York City is very, very different from what we do in the farmlands of Indiana. We cannot have a one-size-fits-all regulation which says that you can only build single-family houses in real estate, which is as expensive as it is in New York City, right? And so we figured out how to layer on different applications, storefronts in the bottom, basement apartments, penthouse apartments. And so we're taking that same piece of real estate and extracting a huge amount of value for it. We have to learn how to do that better in spectrum, and we can do that. I think CBRS has shown us how we can do it. 6 gigahertz, excellent example of how we take 1200 megahertz of spectrum, which is a big chunk, and we layer on use cases. We have incumbents, we have fixed microwave users, we have satellite. We started off with just low power indoor users. Then we added on standard power users with AFC control, very low power. And then the new geofence variable power, it allows you to do fixed wireless access. You can also do 5G, NR, and NRU. So as we look forward to an era where on the one hand, we have an abundance of use cases and applications that need spectrum, but the spectrum pie is not going to grow, especially when we have a bounding box of physics around it, right? Yes, we've pushed the boundaries of physics quite a bit. Cellular at one time was just sub 1 gigahertz. Now we're moving up the frequency band. But the physics has not changed. We have been able to harness some of these limitations and actually take some of the limitations and make them into things that we can work with beamforming and large panel antenna arrays. But as I look and address the question of what went right in 2025, I think getting the auction authority back to the FCC was absolutely the right step. I don't think that, again, as I mentioned, allocating 800 megahertz of spectrum to one way of using it was necessarily driven by a scientific analysis or a technical analysis or what are the use cases that need spectrum. Rob alluded to indoor needs of spectrum, and I'm very focused on that right now in the research that I do. The only place I'll differ from Rob on indoor is I don't think Wi-Fi is the only answer for indoor connectivity. I think there are many, many applications where you need a cellular-like system indoors. But when we allocate cellular spectrum today, we don't differentiate between where the spectrum is going to be used. So if you take this 80% of use cases that are indoors and then you separate out as to which one of these would actually benefit from a cellular system, and when I talk about a cellular system, I'm talking about a 5G stack, which operates differently than a Wi-Fi stack. There are some better quality of service metrics that a cellular stack can provide. And in many cases, like factory automation, warehouse control, in the indoor cases, you really want that cellular stack. And that is where having spectrum that you can use to deploy cellular stack in, like the CBRS band, is essential. But there's only 150 megahertz of it, right? So when we talk about 800 megahertz of spectrum coming down the pike, we should be thinking more carefully about how this spectrum may be used. The final thing that I will say is that, trying this back to the topic, which is license to build. Recently, I came across some very interesting data from the EU has a 5G observatory where they have measures of build-outs across the world. And we've heard a lot about how China is supposedly winning the hypothetical race to 5G. I've never understood what that means, honestly. But if you look at what they're doing, they're a much bigger country. So really the metric we want to look at is how many 5G base stations per 100,000 people do you have, right? Their number sits at 301. Any guesses as to what the US number is? And I'm quoting from that data. It's about 42, right? The amount of spectrum is more or less the same. South Korea is actually an even better comparison. They have 670 5G base stations per 100,000 residents versus US's 42, and they have less mid-band spectrum. So when we think about spectrum and cellular connectivity and wireless, we have to keep in mind that if what you lack in spectrum, you can make up with deployment. Small cells are a well-studied way of doing cellular coverage. Yes, there are hurdles. We heard about permitting and pole attachments and rights of way, all of that, but those are not spectrum issues. So if we are facing a world where we have to figure out how we best use the limited spectrum we have, we should not look at it in isolation. We said, okay, if we have just a little part of spectrum, what can we do in these other places to add to it? So no matter how much spectrum we allocate to 5G or 6G or cellular, ultimately it'll be how much we deploy in terms of infrastructure that we get the most benefit out of it. And I would encourage folks to really think about the targeted use cases, the places in the cities where you need the spectrum, indoors where you need the spectrum, and move away from this blanket one-size-fits-all approach to spectrum policy.
Thanks so much for having me. Really appreciate it. This has been a great conference. I really enjoy it. So real quick, just a little behind the curtain. So for the prep call for this, I realized that I was on a flight and I wasn't gonna be able to make it. And so I asked a colleague to listen in. I was like, it's gonna be easy lift, don't worry about it. And she texted me and said, they all said that they wanna hear what you have to say. And I think they're gonna come after you. And I said, no, come on, it's fine. It'll be okay. And then I saw Shawn, and he said, yeah, no, we decided we're coming after you. And then I saw Rob, and he's like, yeah, no, we are. And at that point, like, Rob's not that funny. And so I started thinking that might be real. So with that, I'm gonna say very little so I don't give them that much to come after me on. Also, I got the benefit that actually Arpan got ahead of me on a lot of the stuff I was gonna say already. So I'm just gonna kind of lean on what Arpan was talking about. From our perspective, a lot of,
say who we is.
oh, didn't I say that? Oh, sorry. I'm David, I'm from SpaceX. And we have Starlink, so we got a lot of satellites that do broadband. So from a SpaceX perspective, talking about satellite stuff, one of the things that really went very well in 2025, it's exactly what Arpan was talking about, is that for a very long time in satellite, there weren't very many deployments, right? You had geosynchronous satellites, they didn't go up that often, they covered a huge part of the Earth, and launch cost was really high. People had talked about doing these kind of next generation satellite systems with lots of satellites, but you were never able, the economics didn't make sense until we had reusable rockets. Once you had reusable rockets, the launch costs go way down, the economics changes, and now you see all these other systems that are popping up. And the old system, the scarcity system, was a very command and control approach, which is very bespoke. We'll know it when we see it. You tell us what we're going to do. We'll think about it, and we'll tell you whether we like it or not. And that was fine for that model. But as Arpan said, everything changed a few years ago. And it's been a struggle, and it's a continuing struggle of how do you shift the regulatory approach to be able to deal with this real, you saw the chart that Arpan put up, this real inflection point in what's going on in space and kind of satellite spectrum. And I think one of the things the FCC has done really well is this pivot over the past year to start looking at, I hadn't thought of it exactly. I mean, they've been describing it as the kind of abundance approach, but it really is, it is starting to look at it of, instead of assuming that space is finite and spectrum and being able to share spectrum is finite, and so we have to look at every single application and dig into it and assume the worst for every single one of them. And let's take a really long time thinking about it, because we got to make sure that we've thought about the worst possible thing that that can happen and cabinet it in. They switched, and they proposed to switch the entire way that they're reviewing it to, let's assume that this is good stuff. Let's put the rules out there, And if you meet the rules, we'll assume that that's good, and we'll review it and make sure that like everything is kind of copacetic and working well. But we're going to assume that this is good, and we're going to default towards approvals rather than default towards, not that it wasn't approvals, but default towards lots of conditions, default towards command and control. And it's switching to this much more flexible approach. And what it's going to do is it's really going to lower the barriers to entry for, I mean, you can think about it from a SpaceX perspective, but you can also think about it, all these new startups all around here. There's a huge aerospace industry all around here. All these startups that are trying to come into the market, they're trying to take advantage of these lower launch costs. And by switching to this kind of abundance approach on the regulatory approach, it's making it much more available to be able to apply, that the licensing doesn't have to take years to get there. You don't need to have literally millions of dollars in lawyer fees to be able to kind of get across the line to be able to get this stuff, to be able to launch your satellites, deploy your system. They put in timelines, they simplified the system. They're talking about changing some old, EPFD, you don't need to know what that means, but it's essentially a power limit that is like from 30 years ago that artificially restricts how kind of the capacity that you can put onto a next generation satellite system. It's all these things that are, let's assume this stuff can do, let's assume that there's good stuff here. Let's assume that we want to approve this. Let's watch it, let's put in guardrails, let's make sure there's rules of the road, but let's assume that this is going to turn out to be well. And it's really going to let the industry flourish. And I think that inflection point, I think we're really going to see, that was applications that ARPAN put up, but I think what we're going to see is actual deployments, actual new services, actual new stuff for consumers that's going to come out of this. Real quick on the thing that I'm really worried about that's coming out of 26. A lot of the rest of the world is watching what's happening in the United States. The United States is getting far ahead in space. A lot of the world doesn't like that, and there's increasing amount of talk globally, a lot of protectionist proposals coming out of other countries. These systems are inherently global. They have to be global. The economics only works if you have a global system. There's a lot of countries, there's a lot of parts of the world that are talking about, actually, I mean, they will just say it. If you come from the United States, we don't want to give you access to spectrum in our country or in our region or continent. And that Chairman Carr has, I think, done the only thing he can do, which is start saying, hey, if you're going to start treating us that way, we're going to have to do that to you too. That's a bad result all around, right? We don't want to go into that world. I really think that this is something I'm seeing that come up more and more around the world of like, how do we make sure we're kind of carving up the spectrum and making sure we get ours and we're kind of keeping everybody else out? If that's the way that we go, it's going to end up, these systems don't work that way. These are inherently global. If we start going that way, it's going to end up being a very bad result. We're going to actually counteract this kind of abundance approach, and it's going to start pushing back into the scarcity again. And I think that's going to end up being worse for everyone.
All right, thank you, and thank you everybody for the very insightful comments. So I promised you this is education time for the students who are in the room or maybe watching remotely, and for those of you who are not close into the spectrum world, because you've heard this term spectrum sharing talked about a lot, but it actually means different things in different contexts. So to bring some clarity for that, we have a lightning round scheduled now. I'm going to ask each panelist how spectrum sharing works in a different category of spectrum. So you've got Michael on the end. He's going to answer for unlicensed. Shawn will talk about it for the exclusively licensed bands. Rob Alderfer will talk about the dynamically shared bands like CBRS. Monisha, I've asked her to talk about federal spectrum. And then David, could you say how spectrum sharing works in the satellite bands? 90 seconds each. And start with Michael and run on down the line.
Okay.
Yeah.
Unlicensed. The starting point is to know, of course, that the FCC allocates bands of spectrum for particular services, and then in most bands assigns licenses to specific operators. But there are also bands that are not licensed at all. They are sort of commons or public park, open to anyone for shared use subject to certain conditions. And the core condition is that you cannot cause interference to any licensed user. They must be protected, as Rob was describing with the fixed links in the 6 gigahertz band. And you must accept any interference from any other user, licensed or unlicensed. Wi-Fi is, of course, the best known example, but there are also, Bluetooth and other technologies for this unlicensed sharing. And so obviously you don't need a government license to operate a Wi-Fi router in your home or a Wi-Fi hotspot. And because Wi-Fi is free to use, low power, and abundant, it efficiently reuses spectrum and ends up carrying between 80 and 90% of the mobile data traffic on smartphones, for example. So that's unlicensed.
And I jump in for license, and I will try to go quick. You hear of exclusive licensing, and I think that's a misnomer when you're thinking about the characteristics of the underlying spectrum. Exclusive licensing means I get a license as a commercial wireless entity to use a block of spectrum, and I am the only commercial user allowed to use that block of spectrum. It gives me certainty for investment and gives me certainty on how I build my network characteristics against that. That does not mean I'm the only user in that band. Oftentimes we have to coordinate geographically or statically with other users. A great example is in a band called the AWS band, we have to carve out geographic exclusion zones for certain government operations, radars, and things like that. So you will have sharing with other types of users in a band, generally federal users, which will define, hey, I can't operate in this space. There's a static space where I cannot transmit into to protect that operation. Sharing and exclusive licensing also happens among the carriers. So, we may have a block of 100 megahertz of spectrum that has been licensed, but we may each get 20 megahertz of those licenses right next to each other. So we coordinate how we operate. We also coordinate by market. In one market, I may have a license for 10. Another market, someone else may have a license for that same 10. So we have to coordinate across that. But we still fundamentally have the commercial right to use that spectrum versus anyone else with interference protections.
So dynamic spectrum sharing, the discussion starts but doesn't end with CBRS, the Citizens Broadband Radio Service, which is frequency range in the 3 gigahertz neighborhood, which has enabled commercial wireless services of a variety of types in the same frequency band that's used by the Navy for shipborne radars. So that's been a really interesting case where there's tremendous commercial use of the band, mobile services, fixed wireless access, and private wireless operations that create value without imposing costs, significant costs on the Navy. And that's managed through an intermediary known as a spectrum access system, which ensures that commercial operations near the coasts don't do any harm to naval ships when they're in town and using the frequencies they need. So this is one example of dynamic spectrum sharing. And to aggregate out a little bit, I thought it'd be useful to quote a report to the President from 2012. The President's Council of Advisors on Science and Technology defined spectrum sharing as spectrum sharing can take a number of forms, but its purpose is to ensure that when the primary user does not need the spectrum, another party can put it to good use as opposed to allowing it to remain fallow. So to embrace Arpan's theme from earlier, creating abundance from scarcity. So the benefit of that is you create a lot of value for new uses of the spectrum while creating minimal costs for existing users. And it's worth noting that consumer data use patterns are highly compatible with shared spectrum as we think about future opportunities. As Monisha and I have talked about, most commercial wireless use happens in specific locations. It's local traffic. And other wireless systems like the Navy example use spectrum in different locations or may not need spectrum all of the time. And so we can unlock significant value through these dynamic shared spectrum constructs, often in concert with lower power levels. So that's a real benefit of dynamic spectrum sharing.
Federal spectrum usage actually covers many, many different applications. And again, for the students in the room, that's NTIA that regulates all of that. So the ones that have been mentioned already are the DoD, Navy radars, AWS coexisting with certain areas of the country. But there's a huge section of federal usage which It has to do with things which are more science related. So you have radio astronomy uses spectrum. These are passive sensing instruments, weather radars that give you your weather forecasts that are looking down on Earth. They're also mostly passive. Earth sensing satellites, which are looking for many other parameters. And these systems are actually are users of spectrum. Sometimes they're active, sometimes they're passive. But giving them room to operate is essential to our functioning as society. I mean, I don't think any one of us want to have our weather forecasts tampered with. They also have different challenges than, say, a Wi-Fi system coexisting with a cellular system, because these systems are inherently measuring extremely low signal levels. Those levels in a commercial system would be noise. So they're really looking for noise, and whatever commercial systems are providing are interference to this. And many times the issues are not so much as to what are the systems that are in the same band that these systems are operating over, but what is in the adjacent band. So the adjacent band spillover can affect a lot of these kind of federal systems a lot. And again, however, a lot of this usage is geographically isolated. We don't have radio telescopes all over the country. Weather satellites go around, so we have to be careful about that. And sometimes they're just limited by physics. So when you're looking at certain chemical elements, they have very specific spectral lines that sometimes happen to fall in, say, the 6 gigahertz band. And so we have to kind of figure out how we can protect these, because the physics is not going to change to accommodate what we need out of our commercial systems. So there are a lot of challenges there, but I think that also provides a lot of opportunities on how you can share the spectrum better.
Thanks. How does satellite shows better work?
Yeah, you see what it's like to be the satellite guy. Like, we get a bunch of people who get to talk about terrestrial in their pieces, and then I have to talk about all spectrum bands across all services in all of space, and I get 90 seconds.
Yeah, but how does the sharing work?
Yeah, so it's actually, so there's a few different models. So all of our spectrum is shared. Our main one is like for our main Starlink service, for example, is in the KU's case. These are fixed. So it's directional antennas. So we use directional antennas, and because we use directional antennas, it's a narrow beam. You kind of know where it is, and so there's rules to kind of make sure that you don't overdo it. And you don't cross it. I call it the Ghostbuster rule. You don't want to really cross the beams, but it's as long as you avoid that, you mostly can operate and can co-frequency share, and so that's how most of that works. There's power limits also. It's, if you think about it, I was mentioning earlier, like the GSOs are really much higher than the NGSOs. So that the geosynchronous orbit satellites are much higher, have giant beams. The next generation, the non-geosynchronous, are all much lower than that. So you can't really avoid crossing the beams doing it that way. So instead, it's a power limit, and so you can have higher power if you're coming from higher, and you have to have lower power when you're coming from lower. That's generally how it does. And then the last one has been, and this is the tricky one where it's like a lot of the sticking points nowadays, is the mobile satellite spectrum, which theoretically is supposed to be shared, but it's omnidirectional antennas, which is really tricky to be co-frequency, right? When you have an antenna that can be scanning anywhere in the same frequencies, you put them next to each other, they're gonna mess each other up. And so there's a lot of questions right now. There's a very kind of live issue of how does sharing work in that, in those bands.
Great, thank you. All right, so now it's time for the everybody goes after David session. But actually, the thing that we were all interested in.
I had the wrong strategy. I should have talked more. Yeah.
No, but there was a very major non-legislative development in 2025. As he said, the mobile satellite world has always operated in shared spectrum, but the big seismic event was SpaceX acquiring exclusively licensed spectrum from EchoStar Dish. So this leads to a lot of questions that I think people on the panel were very interested in engaging in about how this leads us towards the future. Does the rapid growth of D2D and D2C, direct to device and direct to cell, does that change what it takes to offer a competitive service in the telecommunications space? Maybe even should the US start auctioning exclusive use licenses for satellite spectrum, if that's really what it takes to offer a great service? And what does any of this mean for the future of satellite terrestrial sharing? Maybe in the 5G era, maybe in the 6G era, or anything like that. So this is a broad set of issues. So we're very interested to start with David. Anything you want to share about your perspectives on what this meant from the SpaceX perspective, and then get into discussion with the rest of the panel.
No.
Yeah.
No. Okay. So yeah, let me just give a little background on. So there's kind of two models that are going on the direct-to-device. The first model is the one that we've been doing, and in the United States, we're in about 11 countries now that we've announced that we're doing this. But in the United States, it's definitely our biggest market, and we're partnered with T-Mobile. And what we do for this model is we use the terrestrial operator spectrum. So it's essentially what we do is we don't have our own spectrum at all in this model. We build satellites that are capable of operating in the terrestrial spectrum and generally follow the kind of general rules of how the terrestrial spectrum is used. We then partner with a terrestrial operator who has the right kind of spectrum and has it in the right places and can use it the right way. And essentially, we transmit from the satellites in LTE. So we build our satellites to be LTE. So it's so essentially we look a lot like a terrestrial. What'll happen is if you're a T-Mobile customer, is if you're walking around, if your phone can see a T-Mobile tower, it wants to talk to that tower. That's the first choice. If it can't see a T-Mobile tower, it'll start scanning and it will think our satellites are, essentially it thinks our satellites are a T-Mobile tower and it can communicate. Now, it's in 5x5 megahertz. That's not a lot of spectrum to go all the way to space. So we can do things like texting, we can do voice, we can do light data, but you would not confuse this for 5G. It's fine. And it's actually the biggest use case we've seen has been national parks and emergencies. It's been essential in emergencies. You see the usage just spike. And it's like, for example, in Jamaica a few months ago when Hurricane Melissa came through, it knocked out all the terrestrial equipment. Essentially, we had two parts. I mean, we deployed Starlink to kind of have our normal kind of user terminals there, but we also we quickly got agreements with all the terrestrial operators in Jamaica, and we quickly turned on a system that we actually hadn't had there before. And we saw essentially hundreds of thousands of text messages going through within an hour or two of the hurricane coming through. It was the only way that people were able to communicate. So it's like, it really is, like I said, you wouldn't think it's 5G, but it really has important applications. Now, what we've done with the deal that we're doing with EchoStar is we're actually trying to acquire our own spectrum. So that way we're not dependent on using the terrestrial operators spectrum. That has a few benefits for us. One of them is that it's more spectrum. And so we have wider channels. We can actually provide real broadband service over using our Gen 2 system, using the spectrum that we're acquiring from EchoStar. It's interesting because that spectrum actually has a terrestrial component to it. So it allows us that if we need to supplement with terrestrial build-outs, we can do that as well because it's got that terrestrial license in it as well. Whether that, I kind of question a little bit, like reading too much into that one particular deal. There is the satellite spectrum is that mobile service satellite spectrum, MSS spectrum. There are several other bands that have that same allocation and do that. This, because it's terrestrial, has kind of an exclusivity that's built in as part of the terrestrial that's different. Also, if you look at the pricing that we paid, satellite spectrum, because it's shared and because of kind of the history of it and because it's global, is really hard to price. And so actually, if you look at what we ended up paying for the spectrum, we effectively paid almost the same thing on a price per megahertz pop that AT&T paid from EchoStar for purely terrestrial spectrum. Yep. So I don't know how much just this one deal I would read into it as like the whole paradigm has changed, everything is different. We effectively paid terrestrial prices for terrestrial spectrum. So I'm not saying that there aren't changes coming, but I just wouldn't, it's an N of one and I wouldn't over-index on the N of one.
I was gonna say, I'll jump in because I was actually the one on the prep call that raised this, and I can't believe you went Ghostbusters and not Star Wars. Come on, what kind of a space guy are you if you go for Ghostbusters? No, I actually do think there are instructive lessons to think about when you reflect on what SpaceX did and what David didn't say, but I'm going to project onto him because I get the benefit of doing that as Verizon and not a SpaceX partner. Is I think one of the reasons SpaceX bought that spectrum, terrestrial component or not, is the certainty it gives them to be able to make the investments in the next generation of satellites and launch them and know that they're going to have the spectrum platform to do it. We partner with AST. AST is looking at a similar service. They acquired their spectrum rights to do it through a long-term lease, but a lease is inferior ultimately to having the license because you don't have the certainty of having it over time. You're reliant on another partner, and who knows what's going to happen, even on a long-term lease. And the AST lease, I think, is 80 years or more. But it's instructive to think about in the context of this larger conversation about spectrum utilization rights and license versus shared and whatnot, to say that outcomes matter, right? What you want people to do with the spectrum matters. The services that you want to appear out in the ecosystem matter. So for us as mobile wireless carriers, the reason we like exclusively licensed spectrum or licensed spectrum generally versus alternative access models is it gives us the platform to invest on that. And I've actually heard our company's former CEO tell members of Congress and leaders at the FCC and other, he liked investing in the United States because the certainty that the licensing structure in the United States gave him to make the investment in the network to build the mobile connectivity that people will rely on. And I always encourage folks to remember, like, turn off your Wi-Fi on your phone one day, and in most cases, it's going to work just fine. Turn off your mobile connectivity on your phone one day, and in most cases, you're going to be without connectivity for the better part of your day. And if you want to drive the outcome where we still value mobile connectivity, lots of capacity to power that, to power the new services and whatnot, you need to make those investments in the networks. And the way you entice people to make the investments in the networks and the services is to give them the type of licensing rights to the spectrum that makes it attractive to do that.
Yeah, I'm good. Very happy that David made that distinction between supplemental coverage from space, which was first authorized in 2024 on mobile carrier bands as kind of a fill-in, and mobile satellite spectrum, which is, these are global ITU allocations for satellites to serve mobile devices. And it's not just pie in the sky. Currently, as many of you, I'm sure, know, if you have a new iPhone, Globalstar uses a MSS allocation in partnership with Apple so that, if you have a new Apple iPhone, you can text between any 2 points from top of Mount Rainier to the middle of the Mojave Desert back and forth with someone. The problem is, though, there's very little mobile satellite spectrum. And if this is going to be a new form of a new piece of our what's hopefully convergent connectivity between mobile Wi-Fi and satellite, and fill in all the coverage gaps, because the majority of geography in the United States does not have mobile service. So we'd like to ramp that up to, I would to see it to go to 3G level services at least. And so we need more of that spectrum. There's two ways. One, which in SpaceX started this debate, actually, we could potentially share the current mobile satellite spectrum that's been allocated, but that doesn't seem, it's very iffy if it's feasible, to the degree it's feasible, so it might not be. And then the other way is, as John asked us to respond to, is about, well, should we make more of it available, even beyond the ITU, the international allocations? Should we make more available, for example, perhaps from these study bands? 2.7 to 2.9 would be great mobile satellite spectrum if that's potentially available. And if so, should it be auctioned? Currently, U.S. law, the Orbit Act, precludes that. But it only precludes it, I believe, I haven't looked at it in a long time, I think it only precludes it on the bands that have been globally allocated. So if we make a new U.S.-only allocation for direct to cell at between 2.7 and 2.9, for example, it would, I think we could do that even without changing the law. So it's a very, some very interesting opportunities. We'd really like to see a lot more direct-to-cell connectivity.
So yeah, I think direct to cell is really exciting, and I fully agree that right now what we're seeing is mainly service in areas where you don't have any other option. However, as we look forward, we should also look at what it cannot do, as well as what it can do. It cannot serve a lot of people inside, and we've heard about how many people are actually indoors and going to what Shawn just said about turning Wi-Fi off and turning cellular off. I have Verizon in my home in Chicago, and even if that phone is on, I can barely get anything through. So again, it goes back to where you are. If you're spending 100% of your time outdoors, sure, you need cellular. And that's where I think when we think about cellular and space connectivity, we should think about ubiquity. We really want to be connected outside no matter where you are, in a national park, in a rural highway in the middle of nowhere. Of course, Wi-Fi doesn't have a role there. And as we are looking for spectrum allocations, we should also look at it that way. How do I allocate spectrum and make sure the infrastructure is built out? Go back, license to build. You can have, there is a lot of spectrum that has not been built out in the areas where it could be built out. So keeping the applications in mind, what are the use cases you're going to be serving? What is the immediate need? I think is really important as we think about how we allocate between cellular and terrestrial and unlicensed and all of these various ways.
Okay, last chance for a comment on satellite or D2D. Anything, Rob?
David, I'll just say, if you're feeling singled out, that's what happens when you miss the prep call.
Yeah, I know. I learned my lesson.
Okay, great. Now, crystal ball time. Pulling out your crystal ball, what are things that you're watching for in 2026 that will have the biggest impact on the next 5 to 10 years of evolution of the spectrum ecosystem? And I'd like to keep this somewhat quick, and then we might have some time for a question or two from the audience. So crystal ball time. Who wants to talk about what they're looking for in 26?
I'll jump in. So I think in 26, you're going to see continued significant deployments of 6 gigahertz capable Wi-Fi devices. And that's important because it's seeding the next generation of broadband and mobile connectivity. So that's my prediction in the market. On the policy front, I predict that we will start talking a lot more about shared spectrum as we get deeper into the study of the bands that will be studied as a function of the OB3 legislation. I say that because if you just look at the realities of those bands, let me put a little bit of data on the table. In the 2 gigahertz band that you mentioned, John, there's over 1,800 federal frequency assignments. Each of those generally corresponds to a federal system. In the 4 gigahertz band, it's over 5,000. So all of those need a plan, and it's hard to imagine that sharing won't be a part of it.
Let me talk about what I would like to see. So some of the discussions that we've had is about how valuable spectrum is. It hasn't been brought up in this conference yet, but there is a line which is often used as to how spectrum is the lifeblood of wireless. All that is true, and I always think that for a resource that is considered to be so valuable, as a community, we don't do enough to make sure it's being used well. So the measurements, the metrics, and I'm talking about more than just Ookla speed tests. I think Ookla speed tests, you go out there, you get 500 megabits per second. I'm here, I can barely get 10 megabits per second. So moving away from the notion of just speed tests as a metric for how we are looking at spectrum usage, but really looking at coverage. Where is this spectrum actually being deployed and what's being used? I'd love to see more attention being paid to that starting in 2026, and in addition to the attention on shared spectrum, because to do better sharing, we have to understand how the spectrum is being used, and we have to develop better models for modeling interference, propagation. I hope to see a lot of that evolve in 2026.
Okay. Anyone else? Michael?
Go ahead, Michael.
Yeah, I would say very close to Rob here, where I think I'm mostly looking this year at the studies, the band studies by NTIA, to see whether, for example, an ideal situation, if the 500 megahertz at 4.4 could all go to the mobile industry, that would be terrific. And as I said a few minutes ago, 2.7 to 2.9 for something else that's giving us something new, whether it's more for expansion of CBRS type sharing and or mobile satellite spectrum. And then likewise, to see the deployment, the build out of Wi-Fi 7 and, the great impact that's going to have, as well as we've already seen first glimmers of Wi-Fi 8, which will come into focus sometime later this year, which is going to add a whole nother aspect to Wi-Fi where it's more deterministic, where you can prioritize certain applications if you want to. So it'll be very much in a way like 5G in that respect.
Fantastic.
From my perspective, implementation of OB3 obviously hugely important, and Rob and Michael sort of outlined that on the band studies. Probably the thing that I'm most interested in over the next year is how much our domestic conversation on spectrum is influenced by the next World Radio Communications Conference. I mean, there's no secret why the bands were selected for study, because a lot of those bands are also up for debate internationally for mobile telecommunications allocations. So how we as a country engage with our international partners on that and what the conversation internationally is around those bands, that's going to influence some of the conversation here domestically. The other thing is, and it's sort of been hinted at up here, but I'll go ahead and put a finer point on it, is the conversation about the future of CBRS. I mean, there's been proposals out there by multiple different companies, my own included, about what you do with CBRS. We have proposed new devices not dissimilar to 6 gigahertz to bring in higher power limits in CBRS. One of our fellow mobile wireless companies has said maybe you think about transitioning CBRS to a fully mobile band. I'm interested in that conversation, not like the outcome obviously is important, but I think it does put a pressure point on our ability from a policy perspective to think about what it means to institute a shared spectrum regime and then modify that and evaluate it over time. Because that's one of the key characteristics of shared spectrum is the certainties involved in it and how you think about, evolving sharing regimes over time. And there's a lot of pressure on that. And then broadly beyond next year, I think what AI means for connectivity demands and uplink and downlink and all sorts of stuff is going to be really fascinating to see it evolve. But that's not a 2026. Well, you know what? I'm not going to say it's not a 2026 thing because we had a whole day yesterday about how quickly AI is moving. So who knows? By next year when we're sitting up here, we may be talking about uplink only spectrum. Mm-hmm. So, that's a prediction in the future.
Anything you want to add?
Mm-hmm. Yeah, AI in space. A couple things. I actually hadn't thought about it, but Shawn's point on the World Radio Conference, I think, is actually really important. We particularly care. I think the space industry particularly cares. Something around like 80% of the agenda items for the next World Radio Conference are satellite focused. That's not an accident. As I mentioned earlier, the U.S. is way ahead. The rest of the world doesn't love that. And a lot of these agenda items are designed not to be encouraging the American space industry to keep going the way it's going. And I do think that we do need to pay a lot of attention to that and make sure that we're positioning ourselves well as a country. But going back to ARPAN's chart of the number of satellite applications, we're going to start seeing more and more that the deployments are going to be catching up to the applications. I think the intensity of the use of spectrum is just going to go, for satellite spectrum, is just going to go way, way up. And then I mentioned earlier on the mobile satellite spectrum, there's a lot of talk about what's going on. I'm hopeful that in the next year, a lot of this gets settled out and we kind of have a clearer path of how that's going to work and how these spectrum bands are going to play out and how we can make sure that kind of everything is being done efficiently as these systems are actually deploying and actually starting to provide services.
Okay, well, fantastic. Join me in thanking the panel, and we'll make sure that we can get you to lunch.